Hello everyone, nice to see you again. I'm Chris. In this video, I'll show you how to use a Belden module that is the model number seem to be long 09X0 XSL feed line 121212007D01F. It's a module that can support multiple protocol connections, and this time I'll show you how to configure a CC-Link IE Basic. For the CC-Link IE Basic master, you can see IQR is using this time, but you can also use FX5 and anyway that then CPU that support CC-Link IE Video Basic. So in the right hand side, you can see that I also connect not just the IDO and some and couples CC-Link couples IO-Link device in this tutorial. So let's start. So before I continue the videos, let me introduce myself again. I'm Chris. I come from Hong Kong. Now I'm working with some stuff relating to the factory automations. In the left hand side, you can see my blog, my YouTube channel, and Twitter or X. So please follow me if you want, if you like. Yeah. Thank you. Okay, let me have the introductions of these Belden modules. So in here, maybe it's a little bit small, you cannot see very clearly. Actually, there is a loaded switch in here. You can allow you to configure which protocol that you would like to use in for this module. You can use Ethernet IP, Profinet, EtherCAT, Profi, Modulus TCP, or even CC-Link IE Video. And it also support OBCUA and MQTT. And if you operate this module as a CC-Link IE Basic mode, then the IP default is configured as 192.168.3.xxx. The xxx depends on local switch which IP address you are setting. So let me introduce a bit more about the module. This module is ready for IO-Link specification v1.1.3, the 4 IO-Link class A port and 4 IO-Link class port B, and then we integrate web server functions, and power supply is with a M12 power L core. And they also support the CSP plus file over there for you to configure this module to be easily. Okay, let's explain a bit more about CC-Link Basic in this module. The number station is default is 4. Then you can you have the IO with RX is 64 bits, RY is 64 bits, and RWW and RWY is also 32 works. And as I mentioned before, that the web server function is integrated in this module, so you can use the web server functions to analyze the error of the current status of this module, and you can configure each port to be IO-Link or DI or DO. And also you can also configure the ports. You can see the actual status of each port, and you also upload the IODT file to get more information to your IO-Link device. And here there is a status functions system system tab to allow you to configure the IP address or the MQTT or OBCUA configurations. So before you start to configure the CC-Link IE Basic network or with this module, please go to this link to download the CSPP file, the one from here, and then to install in the GXbox. So here is some information that of the IO-Link device I'm using this time. So for example, this one is a smart connector come from NAS Matic. It's M12 and IO-Link version 1.1 with PWM control. Then also have temperature monitoring and LED color display. And this is a M8 connectors of the Moodle IO-Link hub. The order number is 59670. It also have 8 point of compatible IOs. So here is the Controlonix sensors. Then it's up to 10 mm to measure the distance, and it's also M12. So this Amlon sensor is also measure in other distance. Okay, so in this tutorial, I will not use just ladder. You can see in this screenshot that I'm using SD. All the function block, also use the function block, all the code that program in the function block, I'll use SD. And I'll also use the structured data types. And for the main program, I'll use ladder. And for here, I also use the global variables. Okay, I think the basic introduction is enough. Now I will turn on the camera to show you actually what the hardware I'm using this time. Okay, here is the camera that I turned on. then you can see in the right hand side this Mitsubishi CPU is IQR, and you can see that the LAN cable is connected to the integrated network port to the network switch, and also for the Belden module is connecting the same network. For this other three module I'm not using this time, so please just ignore it. In the Belden module that you can see, I connect to different devices that is preference. I mentioned that in the last part of the video. Then they have a Moodle outlink hub. This is a Molex outlink hub, and this is the Omron outlink sensors, and etc. So I think there's not so many difficult things using this tutorial. I think my explanation here is enough, so we can shift to the program side. Let's go. Okay, before we continue to start the program, then let me to introduce a little bit more about the integrated web server functions of these Belden modules. So in here, I set the IP as .3.5, then I access this web server. I can go to status tab, then you can see the module status here. Then I can turn on the force mode. Then I can see red in here. Then you can see the input or output, some stuff like this. Then when you turn off, then you see the FM LED is turned off again. So you can also check the LED status from the web server functions. Then here you can also see the bus now is running or not, the server, the firmware, and the bus status now, and for the each port that you can just click it and then to configure it as an outlink or some stuff. Because now I am connecting this module to the bus, to the CCNI basic, so you cannot change the port setting now. Okay, then go to the port tabs. You can see more details of each port. If you connect the outlink, then you can see the vendor ID, device ID, vendor name, etc. etc. It's very convenient for you to debug or to check the device connecting or not. Then go to the system. The system, you can see the firmware of your modules and the name or the model number, the MAC address, and the bus status, and you can set the IP address. Then you can configure the MQTT configurations, the OPC configurations that for the IoT applications. And for the users, now the default that the user is admin, and the password is private. Sorry, it also uses REST API. It's also very grateful functions. So, and then I'll show you how to install the CSPP files to the GXWorks. Then, for example, open the GXWorks, go to Tubes, and then go to Profile Management, Register, and then choose the file that you want to use, and then just register it. That's all. Then you can use that to configure to your CCNI basic network. Okay, now we can start to go to program. Let's go. Okay, now we can start to make our program. So the first of all we need to do is to create a new project. So open your GXWorks 3 and go to project new. This time I'm using IQR, so just choose our CPU in your series. And I'm using R0, so let's use R0. So this time I use ladder. Just press OK. Just wait a second. Then you see new project is created in your new project create. Okay, so and then first I would save it. Then I'll save it as let's say name. Okay, the first time I would like to configure my connections. Go to connection distance. In default, there's a connections is created here. Double click here, and this connection created by using USB. So connection test, great. Now connection is okay. Press OK. First of all, I would like to upload the configurations first. So go to read from PLC. Actually, on GXWorks, you can also choose which program that you would like to, which part that you would like to upload from your CPU. So in this time, I would like to just upload the parameters. You mean the hardware configuration in Siemens, same, but just different terms. I'll execute it, and then yes to all. Okay. Okay, save it, and then go to parameters. R00 CPU and go to module parameters. And there's a couple things you need to set while you're using IE base. The first one is the IP address of your CPU. So in this case, I'm using 192.168.3.59 is the default IP address. And the second one, need to enable the CC-Link AEF basic setting. The next one, you need to click on the network conversion settings, and then click here. Just a second. So now I have one connection here. If you install the CSP file that on the previous step, actually in here right hand side of the module list, you will find a outlink master in here. Just drop in here to add your configurations, or you can just press the detect button. If you press the detect now, just give me a second. Okay, you find the device down here. Then you can go to click right click, and I think it's online configuration settings, and yes, okay, oh sorry, not this one, it's online parameter process of remote stations, and then you can select and then the rate. Okay, and then you can also press use the right the parameters you will need to config to your IO modules. And actually, but you also can write by using config your parameters by using the web server. It's just up to you. Yes, and finally you need to make sure you set the IP address is it correct. So this time is 192.168.3.5 as configured by the rotator switch, and by default station is used in this IO module, so no need to touch it. Okay, you just want to save it. Okay, so and then the next point you need to set is the refresh setting. Refresh setting is the setting for you to define which device using in the program to update the process IO. So good setting here. So you mean you see the RX, RY, RWR, RWW is the process IO, is the process IO from CC-Link, and then you need to set you refresh from which device. So here I use X, Y, and D from 100 and 100 and 300. So it's up to you. Just depends on applications. Be set they properly range and make sure not overlap to your program use. Right, so you can just close it. Okay, now we can start to make the program. As I mentioned before, this time I'll use structure types, function box, and global label, and ladder. The first time I'll create the conversion types. So go to I think is label. Yeah, label, and there is structure data types. Right click, add new data types, and this time what you need to do is you need to just config the set the name. So in this type I have prepared it. The first one I want to create is the input data, the digital input data that I received from the module. So press OK. Okay, so the first one is what kind of data that you can receive from the module. Please refer to the manual. I will not explain too much in here. I just copy it from the data and prepare. So here you can see that you can also go to show display to set some initialized value, but I don't set in here. So the first 60-bit is the input data of each port, and they also have the data to check the bit to check out the port is short circuit or not, and then you also have the data, the bits allow you to check the outlink communication is okay or not, Okay, so I don't know what happened. Just give me a second. Okay, sorry. So we also have the device to sense is the short circuit or not, and there's some stuff to provide you the state of that module. So you can just configure it to in the instruction manual. This is the meaning of actually what of each device. I'll not explain it too much in here. I'll create other data types. So the other data type I already create is the output data of the digital output data of that of this binary data module. So I will just also copy it from the data I prepared before. So you can reference the menu for the more details. So I just told you that it just provide to turn on the output or turn off the output of each port. And I would like to combine one times. But actually, even if you combine this moment, Xbox will not really compile these two items, because actually these two items not used in your project actually, so Xbox will not compile it. It maybe not make sense, but in some time, but this is the how Xbox really works. So and then I would like to create another one. The next one I would like to use is the data type of my Lex metallic smart controllers, the data type, the input data types. So you can see I use so many times in the tutorial. So I just place in here. For this input, you can get the status. You can get a short circuit or not. You can get the open circuit or not. You can also get all the states of that modules. And then I will create output NASS sorry, DUT NASS out. Okay, so I create the out. So and then just a little bit big. For the output, I will have a on-off command and the PWM command. So with reference menu to get more data, I just config it very fast. Don't explain too much. Okay, then I will have a data type that's to group these two to one. DUT NASS. So inside here, I have a in data and I have a out data. So for the in data, I just press here and go to structure data types. Just press DUT NASS in. For the same one, press DASS out. Save it, and then I can get the new one. And for the next one is for the Omron proximity outing sensors. You don't have too much data. You have a one monitor data, and then some status for example is unstable or not, or too close or error. So just copy it. Let's save it here. And then I don't like the red color of my label. Just compile it. And then I also have a one run outing sensors. So this one is also very used. I use this in so many times in my tutorial. You can use this. Okay, so you also have a detect value and light value, and a status output and alarm and etc. etc. And then finally, I also would like to group this one into a data type. So just put in data, and then DUT, and okay, press in. That's good. And then I have a Muru I think it's 59707, and then go edit. So you can reference menu to get more informations, but I will just, you can have a input status of each port, and then you get the status of its error, is a power supply error or not, or temperature rating, or global status. And next I will define the output of this Moodle module. So for this one, you can reference menu to get more information, that, and by default using port base. So I can turn on the port, each port that I would like to turn on. This is the output structures, and this module is a configurable in I/O. Okay, then finally I have a structure to group this into 2 into 1. Great. Now you do is save it, and then in, oops, and then in data, out data, and here is Moodle in, and this one is Moodle out. Okay, great. Then I have a Molex IO-Link hub with 16 inputs. So just enter the name. And here is a very simple input with a 60 points. So we just input 0 to input 15 with bit data. So finally I have a Control sensors, a smart sensors. It's very great sensors that allow me to measure 10 mm distance. So I also use this so many times in other tutorial. What you need to do here is just copy. You have some status, for example, alarm or not, or OSS1, 2, and the scale link value and the measure value. Okay, I'll save it, and then close all, and then just compile one time. Great, it works. And the next one, I would like to create the function blocks. So you can go to the FB, FUN, right click, add new datas, then choose the program language ST, and then I have SB and ASS is the function block to control my smart connectors. Great. So go open the local label to configure the interface. And the first one, what is the interface you have? I have the in enable. Then I will have in data. One is data that come from the IO-Link master or in other field bus, and then out data is the data I would like to output to the field bus. And after IO data is the data I control and use it in my program. And for in data is a bit as a bit type, and for the in data one it should be work 60-bit work type, and out data is also same. And the IO data is the data that I created before is NASS. And then we like to create the classes. The class is the enable is the input, so it's VOUT in, and in data also same VOUT in, but output is VOUT out, and then for the IO data is VOUT in out. Sorry, in out. Okay, save it and open the program body. So it's a very easy program. Not so difficult. Oops, not some difficult things. I'll give him some space. Okay, so let's start the programming. IO data dot in data dot value status is equal to in data 1 dot dot 0. Okay, then continue. dot in data, and then is source circuit or source circuit, go to in data dot 1, and have IO data dot in data, and then we open circuit, open circuit is equal to in data dot 2, and have IO data dot in data, and then overheat is equal to in data dot 1 dot 3, and have IO data dot in data, and then dot overheat overcurrent is equal to in data dot 4, and have IO data dot in data. You just reference the mapping, define which bit is used, the meaning of each bit, and our counter one is in data dot 5, and the IO data dot in data dot counter 2 is equal to in data 6. Then you go to output data 1 dot 0 is equal to IO data dot out data dot on off command, and then the reference the mapping from the bit 1 to bit 7, it will be the PAWM command. So just do the same thing, out data dot command dot 0, and then out data 1 dot 2 is equal to IO data dot out command PWM command dot 1. What you need to do here, copy here, which okay, 1 2 3 4 5 6 7. 6, no, don't have 7. Great. And here is 1 2 3 4 5 6 7. Great. Then our first function block is finished. Okay, let's just compile it. Oops, no, not this button. Save it, and then compile it. Great. Then we can make other function block. The second one I would like to make the function block is to control my IO-link sensors from Omron. Just add new data, and then make sure I'm using SD in here. Okay, the first thing is same, you define the input in our interface. So I can go to here. Actually should be same, so I just copy this one and save this one. Then what I need to change is change the interface to this one. Yeah, great. And then the next step is I can open my project here and close the not used one, and then press space to give it some space. So I would like to use the AND functions, because reference the menu that you can see the first byte is the data to get the monitor, data. So then true, and then 60 FF, and then in data 1, and then I would like to give him one more buffer in here, so I give it temp data. It should be work in internal. For VL it will be internal data. Temp data. Yes, that's all. And I have IO data dot monitoring data is equal to temp data, and then IO link data dot status output is equal to what? Equal to in data 1.8, and then status unstable is equal to in data dot 9 is a 9-bit, the bit 9 of the work, and then status to close is equal to in data dot C. This one is dot C, and then this one should be dot D. So they will not use bit 10, they will use bits A, B, C to config from bit 10 to bit 60 to 15. Now filing data dot So status error is equal to in data1 dot f. Great. Just compile it one more time. Make sure no error. And then I also have one more Omron sensors. It detect about 500 mm. So just add a new one, and then make sure using ladder, using ST. Okay, and then close unused one, and then only the local. So the first one is will be in, and oops, is the in enable and ABLE, and then you have a in data one of a 2 data inputs, and then I'll have a IO data. It should be the data, the interface I'm using in my project, in my program. Then I have a temp data to use internal. So for the first one, for the input, it should be enable, and then you have a in data one also input, in data 2 is also input, and then for the IO data, it should be in out, and the temp data just keep it internal. So the first one should be bit, and the second one is should be work type, and this one the same. And for the IO data, it should be DUT2M, yeah, this one. And for temp data, is a keep it in work also. So after define the interface, we can start to make the program. The first one I would like to understand temp data is equal to what? Equal to in data 1, send it to the buffer, and I'll swap it. Because the byte order between the Belden module and the Mitsubishi is not same. You can use the parameter to configure the swap order, but I prefer more, in my experience, just swap it in the program is more better. Then you no need to edit any parameters inside your module. And then true and temp data. Great. And the IO data doc in data, and the doc detect value is equal to temp data. Okay, so get temp data, and then we can use the AND functions to the second work. Going to be true, then in data 2, and then 16 sharp /FF, the first byte, and then temp data, and then IO link data, IO data dot in data dot lighting level is equal to temp data. IO data dot in data, and then status control up 1 is equal to in data 2 dot point dot bit 8, and then IO data dot in data, and then status control over 2 is equal to in data 2 dot 9, and IO data in data, and then the alarm, the fair alarm is equal to in data 2 dot 8, and I also have a, I think is this a error, is equal to in data dot C, and I have a IO data dot in data. Oops, this time I can configure the warning bit is equal to in data 2 dot E, and then I have a IO link data dot in data dot error is equal to in data 2 dot F. Great. Okay, we finish. I can just compile it again. Okay, great. Okay, after that, then we'll have a, I would like to define the function block for control my module. modules. So right click, and not module. So make sure to use ST in here. Great. And then same thing, define the label first. Go to label. I have a in enable. Okay, just make it big. In enable, I have in data 1, in data 2, and I have in data 3. Then I have a out data 1, out data 2. Then I have a IO data, and I have a enable signal. Okay, for the first one, it should be input, input, and here should be output, output, and this one should be in out, and the last one just keep it in internal works. This should be bit type, and here it should be work type, and I change it better into beautiful clear name. Oops, it's in. 1, 2, 3. Save it. And for the output, it also should be 1, 2. And for the IO data, it should be mulu. And for the enable signal, it should be this one. Okay. And then we open the program. So the first one I would like to enable is equal to enable, in enable. I'll keep it to a change it to internal signal. Then if enable, and then you can do something, and then not, right? Okay, maybe I also can define a temp value in here. Temp data, it should be okay. So if enable, so enable, I should define 3 temp data, right? 1, 2, 3, and then 1, 2, 3. Okay, 2 and 3. Okay, and then if enable, and then temp data 1 is equal to in data 1, and then temp data 2 is equal to in data 2, and then temp data 3 is equal to in data 3. Okay, and then else, and then else just temp data 1 is equal to 0, temp data 2 is equal to 0, and temp data 3 is also equal to 0. Great. Okay, but I think it is also not enough. So I also define temp output 1, and then temp output 2. We also have some smart way. I just use a stupid way to make it more clear. And then temp output 1 is equal to okay, let's keep it here. No need to use this one. Okay, delete this row, save it, and then go back here, and if enable again, and else again, put the else in here. Okay, so, and then what do you do? So IO data dot in data in data dot pin 4 x0 is equal to temp data dot 0, right? IO data dot in data dot pin x1 is equal to temp data 1 dot 1 dot 2, and copy it, paste 4 6, and then change it to 1 2 3, and then copy same one, and then this indate 2 2 2 2, and then it should be pawn 4 5 6 7. Please reference the menu to get more informations. And then I'll have a IO data dot in data dot error output power supply is equal to temp data 3 dot 0. Okay, then IO data dot in data, and then I have a temperature rating is equal to temp data 3 dot 1, and IO data dot in data dot error error input output is equal to temp data 3 dot 2. Then the IO data dot in data dot DIAs dot 0 is equal to in data 3 dot 3, and then just copy it, paste 3 4 5, and now a 6 0 1 2 3, and then I'll have a IO data dot in data dot global status is equal to in data 3 dot 7. Okay, so this one's 6 and this one's 7. Great. And then finally, that if enable, then here I can configure the output, and then output data 1, output data 1.0 is equal to IO data dot out data dot pin x0. Just copy it, and then 1 2 3, and the outside is 0 2 4 6, and then copy it, and then 8 A C E, oops, and then 1 2 3 and 4 5 6 7, and that will be sticking here. Great. And then if I have problems, I can just put the output data here, and output data 1 is equal to 0, and output data 2 is also equal to 0. 0. Okay, great. I think I have no error in this block. I can compile it. Okay, and then I have a Modix 60 input IO-Link hub. Set it in ST, and I go local label. I have a in enable. I have a in data 1, D1. I have a IO data interface for me to use inside anyway in my program, and I have a underscore enable and able, and now I have a temp data, and then for the input it should be input, and it should be in out, and this one should be displaying internal, and then I will have a bit data type in here, and this one is work data type, and this one is Amron or Modix 60, and this one should be also bit data type and work. Okay, great. And open the program, and then to submit a little bit big, save it, and enable is equal to in enable. Great. And then I have a if enable, then give it and if, and then give it else. Okay, then data is equal to in data1, and else temp data is equal to 0. And then finally we can IO data dot pin 0 input 0 is equal to temp data 0. Great. What you do here is just copy it, paste 60 times. 1 2 3 4 5 6 7 8 9 A B C D E F. Okay, and then here it should be 0 1 2 3 4 5 6 7 8 9 input 10 11 12 14 15. Great. Compile it again, no error. Great. And then finally I have a contact sensors, do the same things. Okay, let's close the unuseful label windows in GXOS3, and then open the find the label. In here I have a in enable, same, and I have into input data in 1 and in data 2, and then I have a IO data, and then I have a internal enable signal ENAPLE, and then I have 2 temp data for me to use in the calculations. Temp data 1, great, and then I think that's enough. So for this bit data type, it should be work, and then just copy to work, and this one choose work also. And then for the IO data, it should be DUT what? This one. And then for the enable, just put the bit here. It's great. Then compile again. Open the program body to configure program. Okay, temp data. You need to configure the enable signal first. Enable is equal to in enable, and then if enable, then plus n here, ent, and then plus else in here. Temp data is equal to in data 2, and then temp data 1 is equal to in data 1, and else just put the temp data 1, temp data 1 is 0. Okay, and the second one you need we can start to get our data. Just reference to the menu to find out which the mapping of your data of your outing sensors. So B0 is equal to temp data dot point 8, and then IO data dot B1 OSS2 is equal to temp data dot point 9, and then IO data dot B2 is equal to temp data 1 data dot A, and then IO data dot B3 is equal to temp data dot B, IO data dot B4 is equal to temp data dot C, IO data dot B5 is equal to temp data dot D, and then IO data dot B6 is equal to temp data dot E, and then IO data dot B7 is equal to temp data dot F. Great. And then I can swap the data, swap the data 1. So because the by order is not the same. Okay, and then IO data dot R32 measure value is equal to what? Equal to int to real temp data 1 divided to 16384.0 and then multiply 100.0 110.0. Great. And then compile it. Okay, so now we finish all the function blocks. The next one we need to configure the global label. So go to the global label. By default, there's nothing here. I configure the data type for configure the label for all the ports data, and then just I copy it. So in this ST1 station 1 and the outlink data in port 1, it should be work with 16 works. And then it's not enough, so go show details, save it, and then you need to configure the class to global, and then copy it, just copy in here, and then need to configure the assign device with D100 because you set the refresh data from D100, so and then you can just copy it. Okay, and then compile it. It's no problem here. And the second one is I will need to configure the outlink input output data. So here is the input output data. Here is DIDO. I configure is as the data type I created before. Don't forget to change it to global, and then you can go to the detail setting. Oops, I think it's this one, and then set the address to 100. Okay, and then the same one, the output set to Y100, and press OK, and then compile again. Now you can see the difference. Now you can see these two data type is changed. The color, the text color is changed from blue to white. It means these two objects is compiled. This works. It compile these two objects, and then we can configure the output data also, and then set it to the global, and then for the first one is 300, and then just it depends on your refresh setting. Okay, so I configure the global data in here, and then I've add one more. It should be global IO link data. Okay, the global outlink data, so details. The first one is I should create one. The first one is with port 1, And then for the port 1, I'm connecting to a smart connectors, and just configure it as a class global. Then you finish your first define. So I'll just copy it from the data prepare from the Excel, and then change it to global. So now depends on port name, the port that actually connecting to your outing sensors. I will configure the port for port 4, 5, 6, 7, 8. Then with different type of sensors. So it's very convenient if you have same type, same sensors, same device, but different ports, more than one port. Then you can just change the data types, and then you don't need to do so much any stuff. This is powerful of using structured data types and function blocks. And just compile it to make sure that no error. Great. Now see all data types you change to white colors, and then now you need to use in the program to compile this one. Go to program and scan main program, and then program body. Okay, let's go. So I'll say sorry first because I'm also not fairly use so many times for the ladder in Mitsubishi. So let's just do it. For port 1, I'm using the smart connectors. So go to here, drop it, and then FB port 1. And then for the EN, just put true in here. So for the enable signal, I'll use GST1.DI in, and then you have a bit for you to check the communication of outing is work or not. This one, great. I would like to change the display a little bit more to easy to see. It should be display, change format, yes. And for data 1, it should be GST1 in data, okay, should be 0, and then GST port 1, and then output data is GST port 1.0, and then for the IO data GST1 is GST1 port 1, and then just convert it to make sure no error. Great. Then we can do it continuously. For the port 4, it should be this one, I think. Is it 2M? Yeah, this one. X2DB. Yeah. Okay, drop in here and change the instant name to port 4. Oh, great. And then say to true. And then enable is just copy from here, port 4, and then for the in data is GST1 0, and for the GST1 port 4, and then this one is GST1 port 4, and this one is our data is GST1. Port 4, should I have the output data? Why have output data? Let me check my here the user. Okay. Well, I just give in here GST. Okay, and then it should be work. Let's compile again. Great. This function will also compile. Then I can add port 5 is using with contact sensors. Then drop it here, and then port 5. Oops. Wait. Port 5. I think I forgot to say something. Yeah. I forgot to set the interface. It's input, and then here should be in out, and then input. Okay, great. Okay, and then oh great, it directed immediately refreshing here, and then true, and then it's port 5, right? So copy here, port 5, and then copy here is port 50, port 51, and then GST port 5, GST port 5, great, and then compile it, great, and then we'll have a port 6, I think, port 6 connecting the Moodle module, and then drop port 6, and here is true, enable is port 6, and then now you have a data port 6, okay, copy here, port 6, and then data 0, data 1, and data 2, oh, it's right, correct, port 6, okay, and then I have a GSTA port 6, here I have the GSTA port 6, and then for data, oops, I can copy this one, and then port 6, 0, and port 6, 1, great. Compile again, great, no error, save, and then I have port 7, is connecting to a Molex module, port 7, great, it should be true in here, true, and enable is a port 7, and then GSTA, STA port 7, GSTA port 7, for this one it should be port 7, right, okay, I put a space in here, let me check again, port 7, great, 0, and then let's compile again, make sure no error, okay, finally I have a point, the last one, port 8, it should be STA, port 8, and it should be true, and for enable, copy it, and here should be port 8, and then okay, port 8, great, and then port 8, okay, great, just compile it, make sure no error, great. Then finally you can create some simple ladder to check our data. SM400 is always on, and then GSTA, you use the DI dot the second one, okay, and then I have the first one, and this is the coilo, so I put the coilo in here, this one is coilo I think, okay, and then just put M0, great, and then SM400, and then M1, other bit. If this one turn on, I will turn on port 1, out data, on off command, oops, it should be coilo, sorry, coilo, GST port 1, and out data, and on off command. At the same time, I put the PWM set point GST1 dot outdata dot command. Great. Then I would like to also see the output data. So GST outlink outdata dot DOY4 or 5. Then I just put M0 as same. And then SM400. And then I will also see the port 6 GST8 port 6 for the Mulu. Then output data dot 0 1 2 3 4 5 6 0 1 2 3 4 5 6 7, and then okay. Then let's have other program is for me to check the input signal. GST8 port 7 input 0 and then 1 2 3 4 5 6 7 1 2 3 4 5 6 7, and then put the M0 and then copy it and paste it here, and then go to 8 9 10 11 12 13 14 15. Great. And then finally I also have some analog signal. Move, they let me to use this function to move the flow data measure value to some local device. And then I'll have move GST port 4 for the monitor data to a new register, and then move port 8 dot detect value to W5, and then move GST port 8, and this time I also have a light value. I think it's a light value. Yes, to W6. Great. And then we can compile it. Great. Okay, all the program is done. We can download it to our CPU. Go to write to PLC, and then click all options, execute, and write. Just wait a second. Turn to run mode again, but by some case you need to restart the power. Okay, and then turn the monitor. Okay, seems the data is okay, and then I think I will turn the camera to show you the result and all the operations of the program. Just wait a second. Okay, so now I would like to show you the data in here. Then for example, now you see the while it's turning on off, and I can turn off the Mulu data. Here, this one, sorry. Turn on, turn off. You see, and I can also turn on off in here. Make sure to see here. I also get the input output data, but I have some confused why this one is very strange. Port 5. Here I'm making a small mistake. Just a second. Let me stop it. Change to 1 and okay, go back to here. Oh great, the rate is okay. And now operate the sensors in here, then you can actually see the change or not. Just wait a second. Okay, I think it's actually check all the data change or not. And I think in the tutorial, this tutorial is the end. I am sorry that I also not very good for ladder and in Mitsubishi, so the reason that I have some troubles, and hope I can see you next time. So please have a good day and see you next time. Bye bye.